Okay, so we've subsetted some data, we've done some queries, we've figured out how to drop duplicates, drop items, add items. We've done some interesting things just to kind of get our data the way we wanted to, but I think one of the important things to look at whenever you're evaluating your data is let's get some summary statistics. So this video group was going to be about getting summary statistics. So one of the first things the analyst should do is understanding their data. If you have small data sets, like less than 200 records, you can visually scan your data looking for patterns. For larger data sets, getting some descriptive statistics helps understand your data structure. So measures around central tendency, dispersion, and skewness of your data are all useful statistics for you to examine. Now, skewness is a measure of symmetry. Or the lack of symmetry. Skewness measures, if this is a little bit of a review, I apologize for that, how long the tail of your distribution is and where it's pointed. If you have positive skew greater than 1, you have central tendency on the left and a long tail to the right. Negative skew is the opposite. Okay? Another way of looking at skewness is when you look at the central tendency, is the mean is greater than the median is greater than the mode. Okay? And for negative, it's just the opposite. The mean is less than, the median is less than the mode. Okay? So this is for a positive skew. This is for positively skewed distributions. Okay? And as I said, negative would be the other way. The mean is less than, the median is less than the mode. All right? Kurtosis refers to the presence of outliers. In the distribution. Large measures of kurtosis suggest high numbers of outliers, both positive and negative. If kurtosis is positive, the values tend to be clustered around the mean, median, and mode. Negative kurtosis describes a flat distribution. All right, so these are all just little measures that you might want to think about using when you're trying to describe your data. And so we're going to use that same sales file that we've been using. So let's write our code, right? We import pandas as PD. We're going to read in. I want to make sure my directory is okay. It is. So we're going to read in pd dot read CSV, and we want to read in, make sure I get my file names correct. We want to read in that sales final CSV. .csv, and I want to change the sales date to pd dot to date time, and that's for df sales date. Okay, so those are, you've seen these three lines before, we've done this before. So we're just going to run these, import that, start my data frame, and while we're typing away, we'll also get it to convert to a sales date. So now let's start creating, or let's start calculating some different statistics. So we're dealing with this data frame, DF, and I want to maybe get some information about, let's go to our variable view. Maybe, well, we don't see the variable yet because it hasn't read in, but maybe we want to get some statistics on our sales dollars. So we're going to put in a bracket, and in quotation marks, we're going to put in sales dollars. All right, and what we want to find out is, and I'm going to do this for all of these measures, so I'm just going to copy this a few times. Right, so I'm going to do a variety of different measures. So the first one I want to do is the mean. So it's dot mean and of the function, just like that. Here I want dot median of the function. I want dot mode of the function. How about the max, dot max? We want, how about, what else we want? How about minimum, dot min? How about, I want maybe the second and third quartile. So how about we look at dot quantile? And here I'm going to define it as, I want the 0.25 and I want the 0.75. So it's going to give me the 25th, and so it's basically giving me my interquartile range. And I could change this to 0.1, 0.2, I can do all of those things if I wanted to. And then here, let's do skew. All right, let's put in another one. Let's do dot kurtosis. And then let's just do one last one. This one's just going to be dot describe. All right, so this is all different ways of getting basic statistics on your data, right? So we'll see these amounts come out here. So let's run each one. So the mean of my sales dollars is $42.59. Okay. Now that is a mean based on 13.5 million records. Okay, so there may be some stuff that just has one sale and some other stuff that says two. Well, that's really, well, let's see what the median is. What's the midpoint? The midpoint is $19.99 for each one of these particular sales. Okay, well, what's the mode? The mode is $9.99. So we sell the most bottles or the most sales dollars in per brand per day. We have $9.99. All right. Well, what's the maximum? $87,418. Okay, that's a lot. What's the minimum? 49 cents. So we have to ask ourselves, what's going on, right? We have a mean of 42.59. We have a median of 9.99. We have a mode of 9.99. So it looks like the mean is greater than the median is greater than the mode. So that would suggest, if we look back up here to skewness, right? Mean is great. This looks like this would be positively skewed. So there'd be a lot of items out on the right side. Okay, let's look at the interquartile range. Okay, so it goes from $11.99 to $39.98. All right, let's see if it is positively skewed. And yes, it's positively skewed, and it's a huge skewness statistic. All right, let's look at kurtosis. My kurtosis, that is an enormous kurtosis, right? So there's a high number of outliers, a large number of outliers, right? And most of those outliers are probably to the right side. All right, so it's pretty big. And now let's try this describe, and let's see what this gives us. Okay, this gives me some more interesting statistics. It was given to me in scientific notation, but that's okay. So it's giving me the max, it's giving me the median, which is the 50%, the interquartile range, the minimum, the standard deviation, which I didn't even put in here. I'm surprised I missed it. Usually I put that in there, but I didn't. So that would be if I want to just get the standard deviation alone. .std, right? That should just give me the standard deviation by itself. And that's what that is. So that's at 153. The mean, as well as how many items that we're dealing with. All right. So it's some interesting stuff, right? So, and what these summary statistics help me do. What they can do is start the brain thinking about other analytical questions. You want to ask. This is always a good first step. When executing any number or any type of analytics. Okay. There are a number of other functions. You see count. You could also see, so here's the function and the description. I'm not going to put the description, I'll just tell you what the functions are, and then you can look up, you can take a look at the script that's on Canvas. So count, sum, MAD, which is the mean absolute deviation, We can get the min, max, mode, ABS, which is the absolute value. We can get the product of all the values, so basically multiply all of them together. Standard deviation, STD, we already talked about that. If I want just the overall variance, or I want the standard error of the mean, that is another function that exists out there. We can do cumulative sum. So basically it's a sum, but it's a cumulative sum, and depending on how you have it sorted, it will sum that way. We could have cumulative product, the cumulative max, and the cumulative min, right? So these are other functions that you can also use in looking at your data.